Hey everybody, today I'm going to go over how to save some time on your electrical engineering homework using MATLAB. So the first thing I want to go over is using the expand function, which is part of the symbolic toolbox. The way you access the symbolic toolbox is you type in syms and then the variable that you want to set. So I'm just going to set my variable to the letter S. You can do multiple ones and you separate them by spaces, but I'm just going to do the letter S. And what this does, you can see over here, it sets it to a 1 by 1 symbol, is it sets it so that you can basically just use the letter S as a variable. Normally MATLAB likes everything to be matrices, so normally any variable either has to have a value or a vector of values or a matrix of values, but this way we can just use it as a simple variable. So the expand function, what that does is exactly what it sounds like. It expands out polynomials. And really all that does is it just saves you a lot of time for when you need to, do some complex algebra. Or not complex algebra, but algebra that takes a long time. And so like let's say we have the equations, I don't know, s to the second power s squared plus 7, and say we want to multiply that by s to the fourth plus, I don't know, something random, 37s plus 3. And we want to multiply those two things together. We just go ahead and hit enter, and you can see here it spits out the answer for us real nice, and we didn't have to do any work, which is great. You can make this as long as you want it to make it. It can be as simple or as complicated as you want, and it'll multiply everything out for you, and it'll put it in this successive order, which is really nice. The next function I want to go over is the roots function, and that's just written just like this. And the way you use the roots function is you have to put in a polynomial in its vector format. So let's say I want to find the roots of this polynomial that I already have written right here. S to the fourth plus 37s plus 3. To do that by hand would be not possible, but would take way too long and nobody would actually want to do it. So the way you put this in is you use the coefficients of the terms, and then it has to go in successive order. So the coefficient of my s to the fourth term is a 1, and now I need an s to the third term, but I don't have one, so that means its coefficient is 0. So I have 1s to the fourth, and then I have 0s to the third, 0s squared, and then 37s to the first, and then 3s to the 0. Type that in, close my brackets, parentheses, hit enter, and here we go. These are 4 roots. It's fourth order, so that makes sense. We have 2 complex roots, 2 real roots. The next function that I want to go over is very useful. It's called the transfer function. And I'm going to go ahead and set that equal to the variable h, or I'm going to set it to the variable h. And the function is tf, and then open parentheses, close parentheses. And what you need to do is you need to put in a numerator and denominator, and it needs to be in the same vector format that I just described. So what I'm actually going to do is I'm going to say numerator is equal to, let's use this right here as our numerator. So it's going to be 1s squared plus 0s plus 7. Denominator is going to be, let's set it equal to this one that we used up here, which is actually, it's just this right here, which I already have, so I'm going to copy and paste that. And now I'm going to set that equal to h, like I said, tf, and then you do your numerator first, and then your denominator second. You can see it even helps you right here with the format. Hit enter, and it spits out the transfer function for us right here. But really what this does is it's supposed to be used for other functions in MATLAB. So free functions that take transfer functions, because you can see here in the workspace that this variable h is actually set to a tf. One of them, which we actually need to know a lot in various electrical engineering situations, is step response. So you do step h, and that gives us the step response right here. We could do the impulse response, which is right here. And then lastly, we could do Bode plots, which lets us know about the frequency response, and you can see here it gives you the magnitude and phase. And so in this presentation I've covered how to use the symbolic toolbox expand function, the roots function, and the transfer function. And I hope you enjoyed it, and I hope it helps you a little bit. Alright, thank you. Bye-bye.